Now as we are done with some concept, let's go for the problem solving. Let's see some problems. Let's see one first problem. It is 112 into 5 power 4 is equal to what? Options will be 62,000 and 70,000. Option B 76500. Option D 77200. This is actual question. Here it is given 112 into 5 power 4, right? So for that, if you assume that 112 into 5 power 4, we can write it as 5 into 5 into 5 into 5. This is the only meaning of 5 power 4, right? So as we don't know 5 power 4, we will just write it in this way so that we will get an answer. We already know, we are very familiar with 5 table, so that's the reason we are just writing here. So this is 5 into 5, it is giving 25, right? And this 5 into 5, it is giving 25 again. So if you multiply this 25 into 25, I am getting 625. So 112 into 625 is the answer, right? Even I have some more multiplication here. Don't go for big multiplication here. As we already discussed 3-digit multiplication with 3-digit multiplication, 3-digit number, but here you can go with that multiplication. But instead, just see if there is one simple logic here. Instead of going for a long multiplication, if you just separate this 112 into 3 parts, then this multiplication will not be taking long time, right? I can separate this 112 into 3 parts, like 100 as one part and 10 as one part and 2 as one part. If you multiply this number with 3 individuals, then you will get an answer like, if you are multiplying this 625 with 100, you will get 62500, right? And if you multiply this 625 with 10, you will get 62510. And this is multiplying with 2. 2 in the sense, just double this number. Doubling is like 600 double is 1200 and 25 double is 50. So just write 1250. Just add this. So I am getting answer 70,000, right? Instead of going for a multiplication, for big multiplications, you can avoid that big multiplication and you can just divide the number. Whichever the number is easier for you, you can divide that number into 3 parts or whatever the required statement. So you can just multiply the number like this, and you will, if you add the answer, you will get the answer. So please don't go for a big multiplications. Like this you can minimize your time. Let's move to the next question. Our next question is, what least number must be added to 1056 so that the sum is completely divisible by 23, right? Let's see the options also. 2, 3, 18, 27, 21. It says that what least number must be added to 1056 so that the sum is completely divisible by 23. It is asking what is the least number should be added for this 1056 so that this complete number will be exactly divisible by 23. This is very simple problem. Let's see how we can do. That is 1056, if we divide it by 23, what we get? We know 23 fours, it is 23 fours, it is 92, right? So 92, if you subtract, we are getting 136. Again 136 can be divisible. 136 5s are 115. So my answer I am getting is as 21, right? So if I multiply this divide this 1056 with 23, I am getting a remainder as 21. So for this 21, how much should be added so that it is divisible by 23? Just if you add 2 for this 21, it becomes 23 and it can be divisible by, then the whole number will be divisible by 23. So the answer is like, if you add just a 2 for this 1056, then the whole number is divisible by divisible by 23, right? Let's move to the next problem. So let's see this problem by using a distal root. Just cancel whatever the 9s are here. So 9 and this is giving me 10 plus 1 11. 11 again I got 2 digits. Again just do distal root, I am getting 2. So 1397's distal root is 2. Just keep that in the keep that there. Even the same digits here, so directly I can take 2 as the distal root. So here for this total I am getting a distal root as 4. 2 into 2 4. So for in among options, for which option I am getting distal root as 4 will be my correct answer. Let's check. Here in the option A, all 9s got cancelled and 5 plus 6 and it is giving it 12. If I add this 12, 13, it is giving me 4 distal root. I got option A as 4 distal root. So this may be my correct answer, but I am keeping it in a hold. Let me try next option. 9 getting cancelled, 8 1 9, 7 and 8 distal root is 8 for this. So this may not be answer. This is not an answer. And if we see here 9 and 6 and 9, so total I got 0 as the distal root, right? And if I see here 9 7 8 9 and 3 4 5, so my distal root is 5 here. So among all the options I got distal root 4 only for option A. In your competitive examinations also, your questions whatever he is giving will be framed in this way. Wherever it is giving a big calculations, multiplications or divisions also we can go with. Wherever we are getting this kind of questions where you have to go with the simplifications, there just eliminate simplifications and directly go for the distal root. Distal root will give you an answer in a less time, right? Let's go for the second question. Next question. Let's see one more problem which comes under distal root. If you apply distal root, you will get the answer in a fast time. So let's see. Here for this, what will be the distal root? Just cancel all the 9s. 9, 5 and 4, 9, 2, 3, 4, 5. So 5 here, sorry, it is 6 here, and here 5 and 6 and 5, it is 11 plus 2, it is 13, it is giving me 4 as a distal root. So here total I am getting 24, 6 into 4, 24, so my distal root is 6. Again I am just adding this 4 plus 2, I am getting 6. So my distal, if I get distal root as 6, that will be my option, right? So let's see in the option A, 9 and 5 plus 4, 9 and 6, 8, it is only just at a 10 plus 16, again it is giving me 7. So this may not be my answer. So if you come here, 9, and 10, 15, that is giving me 6. So this may be my answer. So let's see here, 9, 6 and 5, 9. So it is giving me 8. So this may not be my answer. Let's see here also, 9 and 5 plus 2, it is 9, and 8 plus 1, 9, and I am left with 10, 16. So 16, it is giving me distal root 7. So obviously only for option B I got distal root as 6. I should get an option distal root as 6 in my question. So I got 6 here. So only for option B I got distal root as 6. So definitely our answer will be 5843463825 for this multiplication. So this is how you can go with the distal root kind of thing. Let's move to the next problem. Let's see fifth problem. What is the unit digit in this? We have to find out the unit digit. If we see here, there is a big calculations where we have to go with, that means we have to make lots of calculations. It is not possible for us to find out what will be the power of this 6374 going to with the power 1793. That means it will take lots of time for us to calculate what will be the power value for that. So instead of only if we calculate, then only we will get unit digit, right? So for this, finding this unit digit, this is very important problem. Generally we come across in high level competitive examinations. So wherever it is asked to find the unit digit, just we have some different rules. If you follow that different rules, you will get the answer easily. Let's see what happens with the different rules. Rule number 1, wherever in your base, in your given number, in the base place, a base place unit digit, in the given number, in the base place unit digit, if the unit digit is 0, 1, 5 and 6, that means if you have 0 here or 5 here or 6 here or 1 here, unit digit base place, right? If you have these values in this place, then obviously your unit digit will be 0, 1, 5, 6. It will be the same. Like for example, if you have 7 here, like 637, 1, power something, value like 561, like that. If you have, if you need to find out what is the unit digit for 6371 power 561, as in this base place, as in this base, unit digit is 1, right? So if we have unit digit 1 or 0 or 5 or 6, we will get unit digit as same only. That means 1 power 1 we will get, right? So 1 power 1 will be 1, right? Wherever we have 0, 1, 5, 6 in our unit digits, then the unit digit will be the same as that number, right? Why is this like 0? How many ever times you square it or double cube it, you will get 0 only. And even 1, how many ever times you want to square or cube or whatever it may be, you will get 1 only. Same with 5 and 6, right? So that's the reason if you have 0, 1, 5, 6 in your base unit place, then obviously your answer, your value also will be same, 0, 1, 5, 6. What happens if the numbers are other than this? If in case I have numbers like 2, 3, 4, 7, 8, 9. what happens in my base unit digit? If it is occupied by 2, 3, 4, 7, 8, 9, then what happens? For this we have a particular rule, we will just discuss that rule, and you can apply that rule, you will get the answer directly. So wherever in your unit place, if you have these values, like for example, if you take in this problem, we have 4 here in the unit place, right? So let's take that simple example, 6374 power 1793, right? As we have 6374 power 1793. Here unit digit, base, in base value unit digit is 4. So wherever you have this value, maybe 2, 3, 4, 7, 8, 9, then you can follow one simple rule, that is just take this power 1793 and divide this with 4, right? If we whenever we get 4 in this base place, if we have all these values, if in case we have 2, 3, 4, 7, 8, 9, then for that just take this power value 1793. We have power 1793 for this, right? Take that power value, just divide that with 4. Whatever the remainder you are getting, this is as a remainder, so whatever the remainder you are getting, take that remainder and put that as power to this value. That means for to take that remainder and put as power for this, right? So my answer will be, we have to just take this remainder, that remainder will be a unit digit for you. So that means 1 will be my remainder. So for this 6374 power 1793, my answer will be 1, unit digit will be 1, right? When you are dividing any power value with 4, you will generally get only 0, 1, 2 and 3, not beyond that. So you will have only 0, 1, 2, 3 as remainder. You will be getting 0, 1, 2, 3 as remainder, because we are dividing the number with 4. So just take that remainder and put that remainder to this last unit digit base value, that means 4 power 1. So it is giving me 4. So for this my unit digit will be 4, and if you see here the unit digit is 5 as we have discussed earlier, and here the unit digit is 1. Wherever you have 0, 1, 5 and 6, you can take the same values, right? So my answer will be, for 5 are 20, 20 into 1, 20 only. So my base value will be 0, that is base unit digit will be 0. So see in your options, 0 will be your answer. Wherever when you are finding the unit digit for a particular number, wherever in your base value the unit digit is 0, 1, 5 and 6, then the unit digit will also be 0, 1, 5 and 6. And other than that numbers like 2, 3, 4, 7, 8, 9, if you have these numbers in your unit digit, then you have to take that power value, that particular number's power value, and divide that with 4. Whatever the remainder you are getting, remainder you will always get either 0 or 1 or 2 or 3, not more than that, right? So whatever the remainder value you are getting, take that remainder as power to this base unit number. That means take this take that remainder 1 as power for this, and you can calculate. As it is power 1, so it is obviously 4. So for this value I got unit digit as 4, and for this value I got unit digit as 5, and for this value unit digit as 1. So if you multiply, we are getting 20. In that 20 again unit digit is 0, so my answer will be 0. So wherever you have to find out unit digit value, then you can follow this process instead of going for that long calculations. Let's go for another problem.